Hey everybody, thanks for coming to my talk. My name is Tony Uceda Vélez. I go by Tony UV. I'm here to talk about attack trees or attack modeling for containers as a service. I wanted to just really emphasize that this talk is really more, it's kind of like a psychological attack-centric talk. So as security practitioners, you might be concerned about, well, what attacks exist, what countermeasures can I put in? But really this is all about trying to be criminalistic against containers, different types of containers that are out there. There's also a prerequisite that you have a basic knowledge of different types of containers that exist out there today. Another thing that, just as context for this topic, is that the attack modeling that we discussed really is part of an overall threat modeling methodology. And a couple of years ago, I wrote this threat modeling methodology called process for attack simulation and threat assessment. And it has 7 stages. And really, the focus of this talk is solely going to be on understanding the attack surface for containers. And so it will look at, again, from just a criminalistic sense, not from a software security sense or a software sense or a security-centric sense, because there are different ways to threat model your applications. This is going to be more driven from the perspective of true risk mitigation based upon viable threats and attacks that exist today and intents around compromising containers. So we have a quick brief outline. We're going to talk about, I'm a former debater, so I like there's this acronym in debate called the SHITS, and it stands for significance, harms, inheritance, topicality, and solvency. We won't really talk too much about the solvency part because, again, this is really attacker-centric, and we're trying to just see how can we get into containers and to exploit them. So we're going to talk about the significance of containerization today. We'll talk about some background, which is always helpful to have some context. We'll look into some threat motives, and there will be a vignette or a scenario that we'll depict. Is there anybody from Uber here? No? Okay, good. The reason I bring that up, and I just, it's difficult to really do an attack vignette or a playbook on what an attack model would look like, just hypothetically, because it really doesn't have any context for the audience, which is you guys. So there is a attack vignette that is really geared around attacking containerized web services that are running in the cloud using exposed APIs and containers. And the reason I pulled from Uber is because they've been pretty proficient in adopting containers within their overall adoption model for applications and management. So that's the reason I say I'm not picking on Uber, but I wanted to really exemplify really the causal factors around threats and what attack patterns really come into play when you want to attack any organization that is looking to adopt containers as a service. A little bit about myself. Oops, just forgot that. I'm having to move two things at the same time here. So a little bit about myself. A couple years ago, I came up with this threat modeling methodology with a colleague of mine in the securities field called Marco Morana. He's out of London. And we basically developed this risk-centric threat modeling because the premise around this is really simple. Why spend time in mitigating if the things that you're trying to solve for mitigation really it's not worth anything or doesn't have viable threat patterns? So the whole point with the PASTA framework is that you basically establish credibility and threat assertions. What threats exist today so that you could actually build an attack tree that's viable and credible. So you have to harvest things like threat intel, threat data, but the point is protect the things that matter, protect the things that are likely to happen. And other types of mantras or threat modeling objectives that exist that are security and software centric do a great job in their goals and objectives. However, it's a little bit different in the sense that they're mostly doing it for the sake of security, for the sake of a better software architecture or software deployment. Contact information is there as well. I run the OWASP chapter in Atlanta, and I'm the CEO for a security consulting firm called First Right. So containers have been proliferating for a good while, so it's important that this is now becoming more and more related to adoption in different types of application models. And the significance of containerization is really important because it provides a huge opportunity for obviously decoupling traditional monolithic applications into more individualistic application services. So truly when you go back to service-oriented architecture, we now have the ability to have unique applications and services reside within its own entity, and thereby protecting each entity possibly with different rule sets in truly applying a security onion to each container. There's been a huge adoption. Like many things that are cloud related, a lot of things that in terms of virtualization or cloud, is the driver is cost. It's cost efficiency. It's not necessarily, and it's also about scalability. So the proliferation of all these different, here's kind of a timeline. Containers is really an old term that was implemented with, Unix-related technologies a long, long time ago. So containerization has existed for a good while. How many of you guys, are familiar with like Linux containers or Solaris namespaces? Okay, so a good bunch of you, so that's good. So you have a notion that this is nothing new. What is new is the fact that we're taking this up to the application level. So as we have different applications running Nginx and Redis and Memcached servers, and you think of an application environment to be very monolithic and just only decoupled by the infrastructure that it resides on, like virtual servers or physical bare metal servers. Now we have the ability to have these application virtualization components. So that's great. It's great for, from the functional sense that we can now spin up and spin down any one of these services. So from a functional standpoint, that's very important. Now, why am I talking about this when it relates to attacks? Because one of the common themes that you'll hear me say during this talk is about how many people here know of someone that's been federally indicted for a felony crime? Anybody? Okay. And the reason I ask that is because if you're somewhat familiar with them, you have a notion of kind of like this criminology component or psychological component of premeditation. And if you follow along some of the major breaches, they're the people that attack, or the organized groups that do attack. They have to understand workflow. They have to understand causal factors for adoption of technology. They have to understand what is the footprint of that technology, how it's managed, how it's orchestrated, how it's instrumented. All of these things are very important if you want to be able to attack it. Now, software-centric and security-centric will just look at these components. We'll look at the kernel, we'll look at the host system, we'll look at file systems and UID levels and stuff like that, and that's great. But it's short-sighted to what criminal intents really call for. So the overall landscape around containerization is really changing. You have, here's just a subset of labels that really reflect on technology groups that are out there to be able to manage containers, locally as part of your DevOps process. Orchestrate, a bed or a sea of containers, using Docker Swarm or Kubernetes or other types of solutions that are out there. CoreOS, Rocket, OpenStack, Magnum. There's a lot there's going to be more. There's going to be more solutions out there to manage these containers and repos and to be able to manage the configuration. Again, why is this relevant? Because these are the technologies that if you want to understand how to be able to inject your malicious malware into repositories, or you want to be able to understand the workflows that are inherently flawed. As an attacker, you have to be able to understand the A to B to C in terms of image sharing, in terms of creating a Docker file, in terms of what does the new system development lifecycle look like for these types of services. Okay. Proliferation significance, future attack implications. So non-tech implications, and we'll talk a lot about this today. DevOps team members, network security groups, open source marketplaces and repositories, technology implications that have actually happened to some degree, container breakout via kernel exploits, misconfiguration opportunities, privilege escalation via root, and illicit access control requests. At the bottom here, you see speed of deployment and dependency check freedom, the openness of, again, the movement in which, there's a figure out there for those that saw some of the videos from DockerCon. I don't know, have you guys checked out a lot of the videos from DockerCon? The adoption rate on containers is like 18,000. It's by far the #1 technology being adopted right now, albeit in the DevOps field. So it's largely being tinkered with, and although there's some organizations that are using this full-fledged for production. But the important thing here is that the speed in which these technologies are able to contain all these different flavors of web services, RESTful APIs, and the culture of information sharing provides a ripe opportunity for attacks. And we'll talk about that during this talk. So what does this mean in terms of the threat agents? As we especially look at huge implementations of containerized services where there's orchestration needed, there's going to be a heavy shift to really doing some open source intelligence gathering in order to target DevOps. So you want to be able to understand how your target, if you, and this is again, I'm speaking towards as if all of you have criminal intent for attacking an organization. Now take this as advice, take this as guidance in terms of how you could look into your own adoption of containers so that you can try to mitigate some of these attack patterns that we'll talk about today. But the focus of DevOps really redefines, and you'll see that the easiest way to inject any sort of malicious activity or attack pattern into a DevOps lifecycle is going to be through targeted social engineering. You want to be able to understand the technology footprint, which we've touched upon a little bit in terms of what solutions are out there, what companies are out there really pushing ahead and forging ahead with orchestration software and stuff like that. We want to be able to understand workflows and architecture. The end of generic attack patterns is here. So with now greater layers of getting access to different exposed APIs, and now with the opportunity for containers to provide deprecated privileges, deprecated use cases within those containerized applications, you have the opportunity for security to do unit testing for each container. Now, currently today, that's not happening. Currently today, a lot of DevOps groups are literally running around with their heads chopped off, just simply trying to get acclimated with how to use Docker or Rocket or any of these other technologies. Targeted attacks are definitely going to be on the rise, and a lot of the already existing exploits that have happened in there in terms of remote code execution or privilege escalation patterns have been extremely niche. Orchestration will also play a key, and we'll look at that with some illustrations here shortly. Okay, so thinking beyond AppSec attack vectors, hacking process, this is basically actually something that was pulled from Uber post somewhere. I think it was part of their Uber public repo that they have on Docker Hub. And the whole intent here is that because this is DevOps really embodies a culture of sharing images, of sharing technology, of sharing lessons learned. There is a huge opportunity to learn about what are the tools and what are the workflows that organizations are using in order to manage their containers. So some inherited threat models that we'll look at is that, first of all, so I spoke in Shanghai a couple years ago at Cloud Connect. There's this cloud conference there. And one of the things that I talked about there was the fact that mismanagement of cloud components, and that's going to be ongoing. If you've dealt with Office 365, if you even dealt, even from a commercial sense, if you dealt with other cloud-related services that are out there, you can recognize the opportunity for misconfiguration, cloud operations mismanagement, and that's to the advantage of the attacker. Misconfiguration, there's a lot of there's a huge dependency on the Docker file in terms of what it basically brings to be able to compile a binary image that's going to be basically your Docker image. So the notion that you can taint something as it relates to the Docker file with arbitrary, with calls, wget calls or curl calls to repositories, or to get binaries that are really foreign to what you need that container to do, provides an opportunity for the threat agent in order to be able to get down some binaries into that container and have that published and be part of a swarm of containers that are managed. Tenant hopping is nothing new. It was actually a concern around with VMware and hypervisor and other types of OS level virtualization. So it's the same concern here, that you want to be able to have that isolation between one container and the next. And then broken trust models. So the idea here, for those of you that are familiar with containers, is that each container, so basically what you're doing is you're wrapping an application service into its own individual entity. It has its own IP. It has its own actor that's running that application service. It has application level, it has a namespace that it pertains to. It has control groups that it pertains to. So it's definitely decoupled from your traditional monolithic application. But what is inherent in terms of a threat model is that you have these trust models that fail. There's a lot of implicit trusts, and there's nothing new really when it comes to security. Okay, so now we're going to shift our attention to threat motives and attack vignettes, and we're kind of foreshadowing some abuse cases in DevOps here. And what we want to look at is taking a page from a risk-centric threat modeling. In order to, stage 2 of the PASTA methodologies talks about enumerating your use cases or your technology that you're using. Just like a criminal would, if you're trying to do a simple B&E, breaking an entry into, I don't know, a downtown LA building. One of the first things you do is just simply understand who's going into the building, what are they doing, how are they doing it, and how are they getting in. So you want to be able to understand basic things in terms of use cases and components. And as an attacker, you want to do the same thing for your containers. So you want to be able to understand how is decoupling being done. Now, oftentimes, that is enforced via the configuration of the container Docker file manifest. And you could actually, uncouple some containers by having some misconfiguration, which we'll talk about a little bit later. But the opportunity for abuse is for you to really abuse the trust boundaries between one container and the next. Process isolation. Process isolation is difficult when you have the same actor or process doing it. So just to kind of create a metaphor, if just this gentleman is in charge of making, let's say we could basically personify him as a process in a container. And so he's running, he's running as a process in a container, but he's doing a lot of different actions, create actions. He's doing a lot of read actions. He's building images. He's running, images. He's killing in processes. If the same actor is doing a lot of different actions within your container, then there is really no decoupling of processes, and so that is an inherent risk. So what we're trying to exemplify here is that there's use cases that exist within your application container that can be looked upon to see what abuse cases can we do, if anything. Dependency. So there's an inherent dependency with the host resource, and it's long been known that containers run with elevated privileges with UID 0, which means root. And just recently, with Docker, they just announced like a couple months ago or weeks ago that version 110 or something like that is going to have user groups. So you can now, instead of running everything as root, you can actually have now more user-defined roles for different types of actions in your containers. But that is all at the mercy of the DevOps person who's actually, developing this and really instrumenting the containers. Web-enabled APIs, the benefit here is that there's a lot of them, all right? And so, as with any API, it inherently provides an opportunity for fuzzing attacks, arbitrary commands to be introduced as part of parameters that an API might be expecting. And so you can fuzz those parameters to see what the API appends with in terms of a response. And one of my favorites, because this is really the way I would go about it if I was paid for a criminal, would be to really taint the containers into public repos. And there's private repo, there's public repos, and actually I kind of want to play a little media clip that I don't know if it'll even play, but it's really interesting to see what is the status quo guidance around DevOps people that are out there that are playing with orchestration technologies or container-based technologies, and what is their guidance for adoption, use, and implementation. All right, so targeting container components. So a lot of this will run around the same things that we just covered. So Docker run namespaces. The Docker daemon, again, runs in elevated privileges. And as you see here, you have, why isn't this showing? It's weird. Okay, anyway, there's a discrepancy here. There's some other images here. It basically just shows the stack. And the Docker containers rely on Docker images that you can get from public or private repos. And there's a Docker registry that maintains all of those images. And so the target components, when you're doing threat modeling, for example, you want to be able to identify what components do you want to test for viable threat patterns. Number one is the namespace. What is the namespace in which your container is running? Number two, the Docker daemon. Are you able to define unique UIDs for your applications within unique containers? Number three, what is the exposure level of your APIs internally to malicious possible actors or malware? No one thinks about the malware, and if you look at the biggest threat for mobile devices right now, it is mobile malware, and it's because it's a lot easier to basically package in exploited means via polymorphic malware than it is for a human to infiltrate, access to how these containers are run and operated. The Docker file is really the blueprint for which your images are being constructed. So to be able to contaminate that with illicit commands or configuration to the benefit of the attacker is going to be, a good threat motive. Infiltrate Docker Hub or registry. Multiple options exist given numerous functions with a tainted image, and that just simply says that with a tainted image you have the ability to even have malware uploaded and associated with a vulnerability or exposing a vulnerability within a container image. So I've invented a new term. I wouldn't be really a security professional if I didn't. So and I'm just kind of making fun of myself. So please don't take me seriously. I really don't really care.
You have to have a quote from Art of War too.
What's that?
You have to have a quote from Art of War too.
Okay. So I was thinking about so when you're really kind of social engineering a repository for which there's a high prevalence of pulling existing containers from a repo. I was trying to find it's really not, phishing. It's definitely having counterfeit images within a repository. And that is I'm really kind of focusing on this because I see that, in fact, there's a lot of, there's been a Black Hat presentation that was done specifically on the opportunity of having tainted images within a repository. But the idea is that you serve deliberately tainted images to a marketplace, knowing that you're just casting a line out there, hoping these DevOps, functionally minded engineers are going to go there and consume your image so they can deploy it within their environments. The goal is mass deployment and consumption of images with vulnerabilities or backdoors. That would be phenomenal. Convenience of pre-built images is too tempting. So, when you're starting out and as an engineer, and you maybe are not really too strong in container management or Docker or some of these other technologies that are out there, you're like, sure, I want a head start. And so from a human aspect, it makes complete sense. Like most insecurity initiatives, weak or immature processes around open source security testing, that doesn't happen today. I mean, we consult with a lot of major organizations, and there is just recently, I would say within the past 2 years, a push to test open libraries. Everyone's testing their code that they develop, but no one's really testing what they're inheriting from open source compiled libraries. I think that's recently just starting as an initiative over the past 2.5 years. So as attackers, which we all are, we're going to profit from this and try to exploit it. So weaknesses that have been historically associated with containers have been the absence of user spaces, and also not being able to adding users to Docker groups which inherit root privileges. Now that's recently changed, but that with Docker at least, because they're now providing the ability to have more security in user groups. But again, this is a new security mitigation that's coming out right now in terms of having user groups in Docker. So by the time that this gets fully implemented and used at a wide scale level, it's going to be years. So from an attacker standpoint, we have the ability to profit from this gap. Other misconfiguration gaps, which is commonplace. So this is actually, I did give credit to the guy, Anthony Bellatini, he's an Italian guy. He did a Black Hat talk, and this is really stuff that he pulled out. He had his stats. It's really interesting, just to kind of substantiate this whole dishing, type of notion. So if you look at Docker Hub, you look at how much pre-built containers exist, and then you look at, and this has actually an audio file that goes with it, that I wanted to play, because what I found was this great, advice from this DevOps guy. He's got a lot of, experience functionally with creating, managing containers. He was like, Docker Hub's where it's at. If you just want to get started, you want to throw up a Memcached server, you want to have a, ASP.NET server or whatever, there's containers for everybody. Redis, great. You want it, pull it down, use it, head start. So this is common evangelization that's happening from a functional sense. And as a criminal, we want to be able to say, hey, this is great stuff, because it falls right into the opportunity of providing tainted images. And they don't have to be overtly tainted, They can be just conspicuously just, idle calls that, that could even be having some, having some comments that are misleading, within, Docker files or different manifests within the image, within the image repo. But look at these stats here. It's 100% official images out of 15,000. 90% of official images have vulnerabilities, and no security inspection today by Docker. This kind of reminds me a lot of, and I hate to make another mobile reference, but when I first started out with smartphones, it was the Android, the one with the QWERTY keyboard where you pushed out the first Droid. And that was by far my favorite phone. The reason I don't use Android anymore is just because of the marketplace. And I think the marketplace is when you talk about SaaS-related solutions or whatnot, are really going to undermine the technologies, because the companies like Docker, Kubernetes does a better job because they have more layers, and we'll go into some attack trees that'll show that. But I really think that as a viable attack pattern, it serves as a great attack vector. Okay. So precedents of attack patterns. So we talked about the precedents of some container weaknesses. We want to match those with some attack patterns, and these have actually happened. So there have been vulnerable images across the marketplace. Multiple attack vectors, included tainted images, have had malware references in them, and or deliberately reference components, application components that have had known vulnerabilities, even Heartbleed. Kernel-based exploits. Docker container breakout proof of concept has been well documented. Basically, it relies on legacy Linux containers code found to be vulnerable. That's since been patched, but the point here is that exploit follows an attack pattern that benefits the attacker. The attacker wants to break out of the container to go to other containers that maybe are handling PII, that are maybe handling more important processes. So that attack pattern, as to support a threat pattern that's viable and realistic, makes complete sense. Middle for Docker Hub access, HTTP access by default for Docker Hub access. You have to configure it with SSL. And most, as we know, when you're configuring SSL and you're a functional engineer, you're doing it wrong, or you're doing self-signed certs. So it provides a huge opportunity for attack patterns to do man in the middle. Okay, so the attack surface for containers is, so you have really kind of four major areas. You have the applications in which that run within the container. So again, you have your Nginx, you have your MySQL, you have your PostgreSDB, whatever you want to do. And typically, this, again, I want to stress, I was actually talking to Jim Anko about this outside, that I think, if done well, containers can undermine the security industries, at least from a consulting standpoint, because if everything is done right, you can really apply security to containers in a way that really reduces, it provides a lot of defense in depth, truly. But unfortunately, the state of where we're at right now is that, the newness of DevOps is being done so kind of haphazardly, so it provides opportunities for attackers to really exploit that. So you have the application itself that's running in a container. You have, it's leveraging system services that are basically supporting the container for, let's say, admin use cases, like I want to SSH to my container because it has its own individual IP. It prefers root, to point that out. There's those low-level processes that are running within that same container that basically handle like the NIC, the network interface card, and the networking and the file system and stuff like that. And you have the kernel level. So when you're thinking about attacking the containers that you're instantiating within your own environment, you want to be able to think, okay, what can I do? So from a security or software-centric sense, you want to hit your APIs here. You want to do fuzzing. You want to do parameter alteration. So whatever parameters you're expecting in an API, you want to fuzz that, do that, and continue to do that. We're doing that today, no different here. At this level, you want to be able to see, this is really about hardening the configuration between the low-level system processes and the high-level system processes. And then at the kernel level, there's some mitigation countermeasures that I'll actually talk about at the very end. Okay, so I'm not going to go into, I'm just going to, let's see if there's some animation here, which I thought, anytime you do animation, you always think it's a good idea when you're doing it, but during the presentation, you always regret it. But the point here is that, you have, again, from a kernel sense, this is really a well-defined blueprint of fully developed, fully implemented containers being orchestrated, for wide deployment and consumption management. And it really shows all the different layers of technology in terms of Linux, of Docker for container management, of Kubernetes for pods and namespace management that encompasses these containers. You have DevOps roles, you have Zookeeper, which is basically the area which is going to be responsible for configuration management of your overall container images. And so what I basically noted in these animation is that you have, from an attack standpoint, you have the Docker file, the individuals managing, the configuration of that, the Docker hub and repo, all of etcd, all of the etcd repos, just simply because of what's in these, the privileges in Kubernetes that is awarded to the etc daemon in terms of what it manages and what it has access to, namely secrets, the secrets files, is very important. So, if we were looking again just from where to attack, and you look at it, you might think, well, I want to attack the container. Well, good luck. If you're really going to be a criminal, it's easier. The only way you're going to get to the container is from exposed APIs or from really doing the Trojan horse through images. And so exposed APIs, you could also, rely on client-side vulnerabilities and like Docker clients, trying to attack the clients that are being used at different organizations as an attack within a larger attack tree. But it's so much easier just to simply, implement a Trojan horse through a Docker repo. All right, so again, no Uber people here, right? So I called this actually personal services attack vignette instead of blatantly calling it out. But so this is just kind of a case study that I drew up. And so bear with me as I kind of speed through the PASTA methodology. But number one, as criminals, what are some objectives that we kind of foresee Uber that they want? Well, they want to grow their segments. They have black car service now, they have Uber Pool, now they're into trucking, I heard. They're into trucking. I don't know if you guys read some of the news, but this is really interesting, opportunities there. So, as any sort of like service, like I just took Uber over here actually. So if Uber is down, I'll be pissed. I might use Lyft or something like that. So reliability, continuity is a big objective for them. Credibility amongst riders and drivers, definitely. They want to sustain that. Otherwise, their services really can't be sustained and their credibility can be tarnished. And cross-selling opportunities will provide more revenue growth. So why are we talking about this in an attack-centric talk? It's because as criminals, we want to be able to understand what causes them pain. So objective, you take the inverse in order to be able to take an adverse strategy to be able to say, this is where I want to focus. And then if you're on the flip side, if you do work at Uber, and you want to be able to have a risk-centric approach, then you align the technology and components that support those objectives, presuming that those are correct. So, and then you see what other sort of regulatory things and drivers that actually they might be obligated to support, like data privacy laws, state, federal, EU, etc. Now, moving on, now we understand objectives, what is the technology footprint, and we specifically for Uber. So we want to be able to attack that. So we want to focus on, we want to map business objectives to targets. So how does segment growth and availability and credibility and cross-selling opportunities really map to a target? So there's a lot of different components in the technology of containers that, especially the orchestration of containers, that can provide a DDoS related exploit. So we want to be able to begin to talk about, threat patterns, and our attack trees that follow are going to exemplify that. Did I switch? Oh, I didn't. I'm sorry. I'm looking at two different slides here. So Uber has provided, this is just from some basic black box OSINT stuff, is that Uber's provided an SDK that could be, and that's an SDK that is it's kind of in a public repo on Docker Hub. So to be able to infiltrate that and to be able to contribute to that SDK so that it gets further shared amongst developers is a great way to, again, have a Trojan horse within something that they're providing already within their Docker repo. APIs, exposed APIs, service-oriented architecture, backend services. This is what Uber has said that they're using. They're using Node.js for many services, Python, Tornado, Golang, and Java, backend data stores, React and Postgres for data stores, and Redis for caching. RingPop provides a highly available, consistent hash link for app layer sharding of services. So this is all with this simple intel so that you can basically say, I know they're using containers. Now I know what their app containers might be like. And I'll show an example of that in the next slide. Now, open source intelligence, can easily identify some of their blueprint with the. Have you guys ever been to Built With? It's a great site for OSINT. So being able to look at their exposed APIs to enumerate version and technology and so forth, and then obviously looking at job boards to see what they're hiring for, which obviously is in support of their technology. So here we have an application decomposition, which is really a stage 3 in the risk-centric threat modeling. And what we're trying to say here is that, well, if I want to attack this entity of Uber and their container adoption strategy, I want to be able to, I know they have a public and private directory and Docker Hub. I know that they have an AWS infrastructure, that they actually might have their own trusted registry running there, which this is all the containers. So the idea here is that all the technologies that I kind of listed through the OSINT stuff, which is stuff that they've disclosed, is basically, you could presume, because that's how containers work, you want to be able to decouple all these applications into their own application service so that you can manage them better, configure them better, interact with them with another better. And so you have your DevOps team, and you have certain different things that are key that you might want to look at as an attacker, like the config.json, which basically maintains your credentials in interacting with all these different repositories. So, there's these different use cases, and there's multiple use cases in terms of the building, in terms of running, in terms of destroying, deleting different images. But the other thing too that was identified is that they're also using an LDAP component and the Docker CA, which is interesting. So they might have integrated authentication there for LDAP across their containers. So they might be doing something good there in order to basically validate requests from one container to the next. Now, going much deeper, so we looked at, the other one was a high-level diagram in terms of kind of more of the workflow. This is, looking at use cases specifically around Docker. This is kind of just a generic, and this was really provided by Anthony Bettini in part of his Black Hat talk, is again, going through like a decomposition of different actions that take place as part of like a data flow diagram, or really this is just kind of like a system level call flow in terms of what different commands in Docker yield in terms of actions on the system. So Docker create can start an image, and Docker kill and Docker stop. All the things that are in bold are things that as an attacker you want to be able to say, well, how do these use cases help support an abuse case that I might be thinking as part of a threat pattern? Okay, so we've decomposed the going to stage 3, we want to be able to have a black box, white box approach, but we want to be able to expose discoverable containers, do social engineering, get OSINT. White box approach might be to identify actors on Docker clients, identify shared container nodes. Linus is something to help audit your container image, is a tool. That's an open source tool that help audit your container images. And obviously, if we're looking at exposures in services and ports, you can use nmap, but there's other things like ngrep or that you could use to basically capture what are the call flows between one container and the next. So we've looking at the kind of like the threat prognosis for against containers. We want to be able to see what sort of existing intel exists out there for personalized service attacks. And these are actual articles that have come out with. I don't know if you guys heard about this. This was interesting, where the list, one of the VPs or executives was actually found to be sourced as the origination IP for an actual hack that happened against Uber, where driver data was compromised. So if you're really looking to recruit and pull Uber driver data and get Lyft to build upon their market share, which they might be lagging behind, what better way in order to basically recruit the pool of drivers in order to basically support your service. So this is a viable threat pattern from a corporate espionage, type of example. I'm not implicating anything about the Lyft exec, but this is some other viable threat patterns that you want to look at is IP theft, corporate sabotage, PII compromise, transaction fraud, or hacktivism if the company is pertaining to some sort of like social messaging that's disagreed upon. Now, some threat assertions that we can make from this is that, and we're going to go into our attack trees here, is that number one, we want to steal drivers. We want the attacker needs drivers' contact information in order to be able to recruit them and maybe socialize them in order to flip. We want to be able to know contract terms with Uber, so that may or may not be really related to information that's managed within containers, unless there is a database that actually has contractual terms and stuff like that. A third threat assertion would want to be, I want T1, T2, but want to frame a target or competitor. So maybe in that the actual attack that happened against Uber was actually a frame, because it would be playful to basically, it would be kind of foolish if you're going to attack somebody to basically have the source IP address literally be tied to the VP of infrastructure at Lyft. So threat agents, competition, competitive threat actors, bounty hunters, hackers for hire, or foreign nation state actors. Okay, so let's talk about there's some threats that really need to be supported by weaknesses here. And the weaknesses in orchestration are the following, is that containers run as root and there's a low namespace adoption in Docker. And up until recently, up until the new version, there's no user namespace. There's no user control in terms of assigning different users for your Docker container. Containers are oftentimes shared with root, and there's insecure transport layers that are associated with this. Challenges with client daemons and Docker are that there's actually exploits against the client itself that could provide an attack vector for an attacker to be able to attack the client, so that the DevOps person, and misconfiguration. Now, on container insecurity, you can actually uncontainerize your container by having your Docker file basically have this configuration where you temporarily set the actual container itself to be that of the host. So you're breaking out of your container and you're able to basically see other containers, and that obviously defeats the whole purpose for containerization. So this is an example of misconfiguration, and this is something that Docker has advisories and write-ups for. There is Chroot for archive extraction exploit that we'll show in a second, and a privileged escalation remote code execution. So all of these container insecurity things have been demonstrated and have been resolved and have been assigned their CVEs. But here's one, and this is was shown in Black Hat. This is the Bash and Docker container. It was discovered to be present in 50% of some of the most popular containers that were managed by Docker Hub. And basically this provided a denial of service capability for remote code execution for arbitrary commands to be passed via this exploit. So the idea here is that the x.cgi was basically passed an arbitrary command that was basically ingested by the container, and that basically allowed for arbitrary command code to be run locally on that container. Now this might be mitigated in more largely like Kubernetes or Docker Swarm implementations, where they notice that there's a problem with a container and they can just kill that container and then just go back to a gold image and just simply reinstantiate it. But another one that was found was really related to Elasticsearch. There was this was in 2014. Basically, this one provided a container breakout. So with the threat motive of trying to break out from one container to the next, if you're using the Elasticsearch image or in Elasticsearch version in your container, you could basically use this exploit to break out and go to another container. And there's actually a payload checked into Metasploit on that. So some simple attack trees that we'll look at, we only have 3, is to basically understand, map here threat motives to actual attacks. And it begins by, we'll look at, threat motive, consumer confidence. So let's say we have an attack, a threat motive of creating a downtime. And so one of those DDoS related vulnerabilities or exploits is what we would want to focus on, but we would have to have a notion and understanding that our attack has to actually affect all of the containers that could be called in to replace the vulnerable container that we've attacked. But for going back to the Uber example, let's say I want to create downtime in order to create a competitive edge or a bad consumer confidence in a service, then you could focus on the Docker engine, where there might be a weakness of bad container management in the sense that they pull from a public Docker repo that has basically is running as an untrusted container. It's running an untrusted container app that's running as root. So you pull a container image from the repo, and that container image is now running as root, and you don't run it under deprecated user roles. There is a vulnerable Docker engine, a vulnerability that we just showed, and we do the container breakout exploitation, which allows us to do different things like access the hosts, remove, kill the actual container that's supporting that particular process. And if we can basically weaponize this into something that affects other containers that might be spawned to remediate this attack, then that would be a good example of weaponization. This one is an alternate attack path, and it kind of shows, as attack tree should, multiple different ways to get to your end result. So this threat motive is around, I want to steal drivers. Let's say I'm starting up an Uber, service in China, or and I don't want to have to do all the biz dev work. And so of getting drivers and marketing and all that stuff, it's much more easier. In fact, I don't know if you saw the last 60 Minutes like 2 weeks ago, that did a great job of talking about Chinese sanction attacks for compromising intellectual property, and that can mean anything. That can mean lists of, in this case, drivers in order to get them to flip, but it can really mean anything. But it really substantiates this idea that you want to be able to, instead of building a business up with the data that you need and all these other things, that you steal it. And so this provides an alternate attack path. And I only have a couple minutes left, right? I have 3 minutes left. So I want to be mindful of what slides I hit. You'll notice here that I have, one of the things I wanted to point out here is that you have this nice DevOps person. And the DevOps and the open source community is all about function and sharing and knowledge sharing. And as an attacker, you want to be able to exploit that. You want to be able to manipulate the fact that there's openness and sharing, and you want to be able to, I'm not condoning this, by the way, I'm just saying, this is a viable attack pattern, that you want to be able to, go to the repositories that they trust and they're using, and to be able to taint them with illicit actions, commands, and configurations. If you look at the evil DevOps icon there, the attack vector is that you could also, there's going to be an increase in OSINT or targeting these DevOps people to either turn them or to do what the dishing aspect that I presented earlier. I can't really go through all of the attack trees as I had planned, but this is an orchestration attack which really focuses more on Kubernetes. And with Kubernetes, for those that are familiar with it, it provides even additional layers in terms of overall management and orchestration, because really containers become part of a pod, which are part of a namespace. So there's all these different levels of abstraction layer to provide levels of security and tightening. But still, nonetheless, there's opportunities in which you follow a threat motive of you want to gain illicit access to Kubernetes pods. They do have known weaknesses in misconfiguration that has been recognized by Google in terms where, for example, the secrets file that I mentioned earlier. The secrets file is actually accessible in Etsy by multiple containers that are run, that are basically running in different pods. And that's just a flaw in design. So in order to, if I want to be able to get the secrets file in order to gain access to different containers and again, affect, what's in those containerized environments, then that's a plausible attack pattern. This next couple of slides, I'm just going to kind of go through. It really just tells the story of the human element, an easiest way to manipulate, containers and get to that DevOps scenario. So, just going through, the Docker file manifest that I talked about earlier. This really provides a blueprint for security. So, where do most people, when they're looking to get this, to build their own containers, where do they start from? Again, they go to the repo. And what I did, here is just, look to see who's currently working in DevOps at Uber. And, it was really easy to get and I validated this through cross-checking on different other social media sites, but the grunt of the matter is that there is because of this, again, this culture of information sharing and where you're trying to build containerized solutions, but you really don't know how, and you want to do some lessons learned. There is a lot of people that are out there that are they're associated with a company name, and they're out there sharing, code or images, or they're open to being interfaced with. It provides a ripe environment for which, if you want to infiltrate some of these organizations, that would be a key attack pattern. I'm going to skip to some of the two last slides here. There's a attack library genre that I've kind of created here for containers. And basically this provides a quick checklist for what to look out for when you're wanting to really to try to defend against attack patterns that have existed, have taken place, and are completely viable based upon threats that have actually happened. So this is not fear mongering, this is past tense, this has actually happened. And in support of mitigation, there's a countermeasures library slide that I developed, which is basically what can you do to basically enforce greater security configuration. What tools can you use that are native to some of the OSs and images that you have that are being leveraged as part of each container, and also, what types of activities can you do in order to train your DevOps people? Because I guarantee you right now, I would love to ask this question: how many people are in organizations where their DevOps people are getting targeted security training? Because if there's criminal groups that want to infiltrate them to be able to get into these massive orchestrated containerized environments, it's difficult to do so just with simply going in through APIs and client-side exploitation. It's just a lot easier to do in order to be able to package a Trojan horse into these repos. Sorry I had to run through this, but if you have any questions or comments, please feel free to follow me on Twitter or email me at tonyuv@verspec.com. But I appreciate the opportunity, and thanks so much for your time.